In this video, we are going to discuss how to solve linear inequalities. So before we talk about what to do, I want us to understand why we're going to do what we're about to do. So first of all, let's start with this inequality here. 6 is greater than negative 12. That's a true statement. So let's see what happens if we multiply both sides by 3. So if we multiply 6 by 3, that's 18. And if we multiply negative 12 by 3, that's negative 36. So if we read this, this says 18 is greater than negative 36. Yes, it worked. So I'm able to multiply an inequality by a positive 3, and we're good. It still makes a true statement. Now let's see what happens when we multiply both sides by a negative 3. So when we do 6 times negative 3, that's negative 18. And then when we do negative 12 times negative 3, that's positive 36. So this is no longer true. So when we multiply both sides by a negative, it now makes it an untrue statement because this says negative 18 is bigger than 36? No, owing someone 18 is not having more money than $36. So that is not true. Now let's say we divide both sides by negative 3. So if we divide this by negative 3, that would be negative 2. And if we divide negative 12 by negative 3, that would be 4. Again, this is no longer true. So it does not work if we multiply both sides by negative 3 and if we divide both sides by negative 3, because negative 2 is not greater than 4. Now if we add 3 to both sides, we'd have 9, and if we'd add 3 here, that would be negative 9, and that is true. 9 is greater than negative 9. Now if we subtract 3 to both sides, we'd have 3, and we'd have negative 15, which is also true. 3 is greater than negative 15. So when we multiply and divide both sides by a negative, it doesn't work if we keep this symbol the same. So when we're solving an inequality, you're going to solve it just like an equation. So when we're solving this inequality here, we want to get the x by itself, so we're still going to do 5 minus 5 like that. So you're still going to solve it the same way. 1 minus 5 is negative 4. But if you multiply or divide both sides by a negative at any point in the problem, if you divide or multiply both sides by a negative, you must reverse the direction of the inequality symbol. So when you divide or multiply by a negative, it's making both sides signs opposite, and therefore then it doesn't make it a true statement. So what you're going to have to do is take these symbols and you have to flip them, and then it would read correctly. So in this problem right here, to get rid of the number next to the x when the variable term is by itself, that is when we divide. So we need to divide by a negative 2. So because we're dividing both sides by a negative here, this symbol needs to switch. And then negative 4 divided by negative 2 is positive 2. Okay. So then we're going to go ahead and graph it. So we're going to put 2 on our graph. And then we talked about in a previous video when it has the line underneath, we need to put a solid circle or a bracket. And then to know what side to shade, we think of this like an arrow, and it's telling us go to the right, or I'm sorry, go to the left. Or the other way to know what to shade is this is saying shade the side where the numbers are less than 2. And these are where all the numbers are less than 2 over here. Okay, then it wants us to write our answer in set builder notation. So set builder is where we have the curly bracket and the variable in the problem is x, and then we put a vertical line. That means such that. And then we're just going to write our answer right here. That. Now interval notation is where you look at the graph from the left to the right. So we always put parentheses around infinity, and we put a negative because this is the negative side on the left, and then a comma, and then it stops here at 2. And we're going to put a bracket there because 2 could go back in for x in this spot. Okay, and then just as a follow-up to make sure we understand what this is saying, it says, is 5 a solution? So to know what side of the graph to shade, you could follow the arrow like we had discussed here. You could read it or ask yourself, pick whatever number you want, so let's pretend it was 5, and ask yourself, is 5 less than or equal to 2? No. So 5 doesn't work here, so we know that that's not the side we shade. Now if we go back to the original problem, to make sure it makes even more sense, this 5 right here, if we plug it in here, and we do order of operations first, so we multiply first, so -2 times 5 is -10, bring down the 5, and then 5 minus 10 is -5, it does not work. -5 is not greater than 1. So that's why you don't shade the side where 5 is. 5 would be over here, it shouldn't be shaded. So you're shading this side because all these numbers, when you plug them in for this x, will make this side greater than or equal to 1. So that's the other way to know where to shade. Plug in a random number. If it works, shade the side where that number is. Alrighty, let's go ahead and try another example. So the first step when we solve this inequality, we're going to solve it just like a regular inequality or regular equation. So we're going to simplify first. So combine the like terms. So 8 minus 2 is 6x, and then plus 10. And then we want to get the variable, the 6x, all by itself. So to get rid of that 10, we need to make it make 0. So subtract 10 on both sides. -5 minus 10 is -15. And then to get rid of this number next to the x, when this is all by itself, that is when we divide. So we're going to divide both sides by 6. And there were no directions saying fraction or decimals are okay. So a negative, so we're going to leave it as a fraction. So a negative divided by a positive is a negative. And 3 can go into both of these numbers. Okay, now if I check it with my calculator, if I do -15 divided by 6, it gives it to me as a, so -15 divided by 6 is -2.5 as a decimal, but we want to keep it as a fraction. So we're going to click second FD, and then it's going to give me a mixed number. This is the same thing as if I had said this. Okay, so either of these would be okay, but I like to keep my answers as improper. So then we're going to go to our number line here. So you could put -5 halves here. You could put -2.5 instead if you want it as a mixed number. And then to figure out where we shade, one way is to read this. This is saying shade all the numbers, and this makes an L for left or less. So shade all the numbers that are less than -2.5. So the numbers that are less are over here on the left. Okay, then we know, because it doesn't have the line underneath, that we need an open circle or a parenthesis. Now the other way to know how to shade is we can think of this as an arrow, and it's telling us go to the left. Okay, and then the third way to know where to shade is we can think of what number, or we could put a number here. So a number that is less than -2.5 would be like -10. and negative 10 would be somewhere over here. So this is the side that you shade because it's the number that would make the statement true. Okay, so now as far as set builder notation, we're going to put the curly brackets. Again, it has the word set, builder notation. And then the variable in the problem's x, so we're going to put x, and then a vertical line means such that. So all the x values such that, and then we're going to copy this answer here. So x is less than negative 5/2. And that is called set builder notation when we write it like that. Interval notation is where we look at our graph and we go left to right. So it's going negative, it's going infinitely, all the negative numbers here to the left of negative 5/2. And then it stops at negative 5/2 and not included. So again, parenthesis was here because this did not have a line underneath. Now notice in this problem we did not switch the direction of the symbol because we did not divide by a negative. We divided by 6. So even though the negative 15 is negative, we did not divide by a negative. We divided by 6. So the symbol did not switch from what it was to begin with. Okay, so if we take a look at number 7, the first step is to simplify, so we're going to distribute. So 2 times x, 2 times negative 3 is negative 6. And then we want to get the variable all by itself, and the problem is there's more than one. So I'm going to go ahead and get rid of 1. I'm going to go ahead and do minus 2x. So again, you could have done minus 5x, but I like to have the variable first. Totally optional. Okay, so then to get this 3x by itself, we have to subtract 9 to both sides. Negative 6 minus 9 is negative 15. So they have the same sign, so we're adding them. That's why it's negative. And then 9 is bigger, so negative 15, remembering those integer rules. And then the very last step, when you have the coefficient and the variable all alone like that, then we divide by this number right here. So we're dividing both sides by 3. So since we're dividing by a positive 3, the symbol stays the same and does not get switched. So even though we're dividing with a negative here, we're not dividing by a negative. We're dividing by a positive 3. Okay, so now to graph it, we put our negative 5 on the number line, and then we're going to use an open circle or a parenthesis. And then to figure out what side we shade, we could either think of this like an arrow, and it's saying shade to the right. Or we can look at this as it's saying shade all the numbers that are Pac-Man greater than, which are on this side. Or we can think of a number that the Pac-Man would want would be like 6, and 6 is on this side of negative 5. Okay, so set builder notation, we need our curly brackets. The variable in this problem is x, so such that. And then we're going to just write this right here. And then interval notation is when we go from the left to the right. So it's going from negative 5, parenthesis, because it's an open circle, and then comma, and then it goes infinitely to the right. And we always put parentheses around our infinity. So when you are doing your test or your homework, you may not have to write it both ways, so just read the directions and see what it asks for.